How you doing? It's good to see you back. One of the first lessons that we learn in programming C++ is that our programs are built out of the building blocks of functions. Your first program was probably something like Hello World, or take some data and just simply send it out to the screen. And in order to accommodate that or accomplish that, you simply used the main function and did your output, any input that you had right through there. So we're going to start to branch out now. We're going to talk about designing and building our own functions. What kinds of things need to be considered when we build functions, when we design things. What is it that we want to accomplish with those functions? And then we'll take a little bit of a look at how to accomplish this. When we talk about programming design and deciding what goes into our functions, there are a couple of things that we want to keep in mind. When we are looking at the algorithm or the ultimate objective of what our program is, the first thing we want to decide is what are the subtasks that occur within our program. Just real simply, if we took a program that gathered input from the user, that would be a subtask. Then it took that data and it processed it in some way. That would be a second subtask. And finally, probably some kind of an output output task, and that would be a third task. So when we think in those terms, we begin to naturally fall into what would comprise the functions that we design and build. So think first about the tasks that you want to accomplish. The ultimate objective then is achieved by that series of tasks, and one by one we process those, and then finally we end up with the result that we're looking for. So when we begin to think about that, a secondary thought comes into play, and that is the idea of reuse. If I write an input function that asks a common question, do you want to continue, yes or no? I'm going to use that over and over and over in my programs. So I'm very careful to design that in the most generic fashion possible, so that when I want to use that in another program, I can either copy the code, which is a simple way, or I can place it in a library and then include that library in my code, and then I have access to that get yes or no function anytime I need to use it. Once I've debugged it, once I have fashioned this function, debugged it, make sure it works, make sure it's efficient, I never have to write it again. And that points us to the third thing that we want to be on the lookout for. When we first begin programming, we have a tendency to create a lot of redundant code. That is, we repeat a lot of things. So let's go back to the example we were just talking about, the get yes or no. That may occur 5 times in a simple program. Do you want to continue? Yes, no. And if I write that code 5 different times, that's 5 opportunities for me to introduce a bug into the program. So I'm looking now for items, lines of code within my program that are being repeated over and over and over, series of lines that are being repeated. Those are ideal candidates for functions. We can take those functions, again, either copy the code or put them in a library and then simply call the library into our program. So we're going to talk about the types of functions that are available to us in their most basic form, how they're structured, what makes them different from one another, and then how to write them. So at the end of this video, I will go over to the code editor, we'll assemble an entire program, and then we'll use the debugger to step through there and see how the different components of our functions are working and serving our larger program. Now, in order to do this, I've come up with a real simple program, and that is a program that gets input from the user, does some processing on it, and then outputs the result back to the user. Nothing fancy, simple input, simple output, simple processing. But in doing that, It allows us to create three different kinds of functions. And once we know the mother forms of these three different kinds of functions, it becomes real simple to then build bigger and more complicated functions. So we are going to create something called getInput, something called process, and something called output. Not terribly original, but they'll do the trick. The one additional thing, the word or the vocabulary word I want to introduce to you is the word signature. A function signature is its description, and it's the way in which the rest of the code recognizes your function. The function signature is composed of a return type, and that return type tells your program what data value is returned or comes back when your function is executed. We have an identifier, which is simply the name of our function, but you have to remember all of the rules that apply to C++ identifiers. So we have the identifier, the return type, and finally we have a parameter list. The parameter list tells your program what values are passed into your function. Now you can pass values out, but that'll come later on. We'll discuss that in a later video. For now, everything that's in your parameter list is being passed in to your function. And what that allows you to do is, let's say we're going to get some input from our getInput function, take that input and feed it into our process function, and we can do all this without using those nasty global variables. So let's have a look again at the code and see how we construct each one of these types of functions. So if we go back and we look at our program design, we'll start with the output function. This is a good candidate because it's going to be a void function. Think about this task for a second. You have processed some data values, and now your last task is to output those data values to the screen, for example. In doing so, there is no processing. There is no value that is going to be returned back to the calling function. It's simply going to output the data and then be completed. This type of a function that doesn't return a value is known as a void function. Void is a keyword, and it tells the compiler that nothing comes back from this function. It will also not expect a return statement at the end of your function, simply because nothing is being returned back. So if we look at this example of the output function, we have the return type void, the identifier output, and a parameter list that contains an integer parameter called inval. Inval will pass a value into the function, and wherever we see that identifier inval, whatever value is passed in will be substituted into that position. So let's say, for sake of argument, that inval received the value of 10. When we execute this function, it will pass down to the single statement, the cout statement, print the value is onto the screen, followed by the integer value 10. Because it is a void function, there is nothing being returned to the calling function, and so there is no return statement. The function simply exits and returns back to the line at which this function was called. So this is a void function. Another type of function is a value returning function. A value returning function is one in which a value is sent back to the function that called this function. This is a value returning function called getInput. We notice that is going to return a data type of integer, and what that means is that the calling function will expect to receive an integer assigned back to it as soon as the execution of this particular function is completed. So let's trace this down line by line. We have a variable called value declared and initialized to 0. We have a prompt and an input statement to gather the value from the user. So the user sees the prompt, he types 10 at the screen prompt, and that value, the integer value 10, is assigned to the variable value, which is then returned. That final statement down at the bottom that says return value takes that 10 that the user assigned to the variable and returns it back to the calling function. So if we called this from main, let's say we said x equals get input, then the 10 that the user had given us in this function is returned back and assigned into that variable x. So this is a value returning function. This will make a little bit more sense in a few minutes when we look at an actual operating program and we can see the data being passed back and forth. All right, we have a parameter list in the function process. Now what parameters are in this early going are values that we are sending into the function. So whatever we have passed into in value, whatever we have assigned as a parameter to this list, is received and available inside of process. So we'll go line by line again. We see integer out value, that is a variable declared and initialized to 0. And basically we are saying out value equals whatever that parameter value, whatever, let's say it's 10, multiplied by the constant multiplier. And so we'll say that equals 10 as well. So it's going to take 10 by 10, assign that result 100 over to out value, and then we're going to return out value. So the parameter list allows us to bring data into the function for further processing. So you combine all those things together, the return type, the parameter list, and then the process within the body, and you have a complete function. Standing on its own, it's difficult to see how all of these things operate. So now we're going to switch over to a program that is built around all of the functions that we just saw. And what we'll do is use the debugger to trace values that are being passed back and forth from each of the functions. Here I've taken all of the functions that we just talked about and put them into a working program. Now the program doesn't do anything spectacular. We'll go ahead and execute it right now. And we can see that all the program does is ask for a value. So we'll type in 10 and return back whatever the process value is. So it's going to be 10 times 20, which equals 200. And sends it out to the screen. But it's a good program because we can very easily trace how the data flows within this program. So we have our three functions: output, get input, and process. Now what you see right here are called prototypes. And what a prototype is it tells the compiler what the function signature looks like. A C++ compiler reads from top to bottom and it processes the code in that fashion. That's why we put our preprocessor directives up here at the top. We declare our constants out in the global workspace, and then we place our prototypes here. That way, when the program encounters one of these function signatures, it recognizes what the return type is, it recognizes what a parameter list looks like, it recognizes those types of things, and it can go ahead and compile them together based upon the promise that it will find the body or the actual definition of the function later on somewhere in the code, maybe even out in another library. But we'll touch on that as we look further into functions. For now, we've got the prototypes here, and down at the bottom we have the actual definitions of our three functions. Remember, process has a parameter list of in value, getInput is an integer value returning function, and output is our void function. So let me walk you through the code. Back in our main function, I have declared a couple of variables. Really not necessary, but it'll add some clarity to what we're trying to see within the program. So input value initialized to 0, process value initialized to 0. The first thing that we do is we're going to call the function getInput. And getInput is a value returning function with no parameters. So we provide an empty parameter list right here. And the process that the program will go through is it will actually leave main and go out to getInput. So execution will skip down to the very first line of getInput, which in this case is that variable declaration. The prompt, get the value, and then it returns whatever value the user types in at the screen. In our previous example, that was the value of 10. So when that function is done executing, the value that the user has typed in gets assigned into the variable input value. Now I'm going to use input value in my process function parameter list. So whatever value is in here will get placed in here and will get passed into the parameter called inValue. So whatever is in here, the value of 10, let's say, is going to be copied into inValue and then used within process. So again, process is going to execute. Execution will transfer to here, so out value is declared and initialized. The 10 that the user provided in the variable input value, it comes in here as in value, is multiplied at times the constant multiplier, passed into out value, and then returned. So process value returns whatever the result is of the processing function. And then finally, process value, that variable, is passed as a parameter to output, and output then simply takes that value and ships it out to the screen. So inval, the value that the user typed in is executed in that way. Now what I've done, remember our design goals, we want to break down the individual tasks that are necessary for the operation of our program. So I think we've done that pretty well. We have an input, a processing, and an output function. You may have a lot more than that. You may have fewer than that, depending upon what your objective is in designing your program. Remember not to get too terribly carried away. For example, when I was talking about granularity and over granularity, we could conceivably call, let's see, two different functions just to do getInput. I could have one function that passes the cout value, and then another function that gets the input to that cout value, returns it back to getInput, which returns it back to, and on and on and on and on. So be careful you don't get, you don't devolve that far unless it's absolutely necessary. Now, having looked at the code, it's really a little bit more interesting if we trace the code. So I'm going to place a breakpoint right here, and we will trace through the program as it executes. Okay, so you see the little red dot off to the side over there. That tells me that that's my breakpoint. The arrow tells me that my program has executed so far, but is stopped waiting for my next step. Another interesting thing, if you'll look down here at the bottom, you will see the two variables that have been declared inside of this scope. So input value and process value both are initialized to 0. You see their current value is 0. Now what I'm going to do is step into getInput. So we have jumped down into this function, and we're going to step through the process that this function goes through. So we step down. It's going to declare a new variable value. Now I want you to notice when we talk about initialization, look at the value right now. it's garbage. So it is going to declare that, but it has not yet been initialized. As soon as I initialize it, I know that it has a safe value in it. So I'll press down, and you'll notice here that my value has turned to 0. So I'm going to step through these because the user needs to input a value. So let's do something exciting. 46, and we'll press enter. And now the variable value now contains the value of 46. So that is a value that is going to be returned. Remember, this return statement fulfills the promise of this integer return type. So I'm going to go back, and I've returned to main. You'll notice now that input value, because we haven't finished this statement, is a 0. And now it equals 46. So now, when we call the second function, this input value becomes this input value, becomes the parameter value. So we'll do the same thing. We will step into process, and you notice that in value got copied the 46 from the variable up in main. So it's copied 46 in here, and that's what we're going to work with. And so again, variable declaration, processing statement. So out value at this juncture equals 0, in value equals 46, multiplier constant equals 20, so it's going to be 20 times 46, which is going to get assigned into out value, and we see that that equals 920. Again, return out value, return the result here. That fulfills the promise of the integer return type. So we pass that. And again, process value, because we haven't completed the statement yet. As soon as we step past this, the value of process value will equal 920. Now, I want you to note something here, that even though we copied this variable in there, nothing has happened to it. It was not modified within the function. It was not affected at all by the function. We will talk about different types of parameters later on, but understand that in this default type of parameter, a copy of the variable used is made into the parameter list, and that the program works with that copy. All right, we step one more, and process value now equals 920. We're going to pass 920 into the output function. So we just have a cout statement here. The value is, you see in val, the parameter received the 920. You pass through, and there it is on the screen. Now, using functions is the way in which you're going to build all of your C++ programs. Main is your core function, but as you begin to design what you want to accomplish, you will design functions that fulfill all of those tasks. You will break your task down into these functions and then simply call the function to do what you would like it to do. It is also possible to call other functions from within other functions, and so on and so on. You can do that a couple, 3, 10, whatever layers deep, as long as the logical flow of your program makes sense. So it is not necessary that they only be called from main. So that should serve as a good introduction for you to C++ functions. Go out and take a program specification, something that you want to build, design the tasks or decide what tasks are necessary to accomplish that, design functions that fulfill those tasks, assemble those blocks together, write them up in a program, and make it work. Good luck to you.